Hi guys, today we are going to study about Laplace transform. Laplace transform is a concept in mathematics which is used for solving differential and integral equations. In physics and engineering, it is used for analysis of linear time invariant systems such as electrical circuits, harmonic oscillators, optical devices and mechanical systems. So, what is Laplace transform? A transformation in general is basically transforming a mathematical expression into another equivalent simple form. Like the transformation logarithms convert multiplication, division, powers into simple addition, subtraction and multiplication. So a simple definition of Laplace transform is, let's say we have a function f of t of the variable t which is defined for all positive values of t. Let s be a real constant. If the integral 0 to infinity e to the power minus st f of t dt exists and is equal to f of s, then f of s is called the Laplace transform of f of t and is denoted by this symbol L of f of t. So this is how we write it. So now there are two sufficient conditions for the existence of Laplace transform. So the two conditions sufficient for the existence of Laplace transform are f of t, that is our function should be of exponential order, and our function should also be a piecewise continuous function. So f of t being of exponential order basically means that the limit of that function tending to infinity, when t tends to infinity, e to the power minus st f of t should be equal to 0. In such a case, we can call the function of exponential order. And a piecewise continuous function is basically a function which is defined on any interval a comma b, and that interval can be divided into a finite number of sub-intervals such that in each of the intervals f of t is continuous. In other words, f of t can have only finite number of discontinuities. For example, if you look at this function, we can see that the function has discontinuities at t1, t2 and t3, and between the intervals the functions are continuous. Now there are certain situations in which we can't determine the Laplace transform for a function. These situations are called indeterminates. So we have 7 indeterminates. Number 1, 0, 0. Number 2, infinity, infinity. 0, infinity. Infinity into infinity. 1 to the power infinity. Infinity to the power 0. And 0 to the power 0. So I'll explain this using an example. Let's say we want to check whether this function is exponential or not. So now, by the definition of exponential order, should be equal to 0. Now, if we write this in this way, and we apply the limit t tending to infinity, we get this function to be of the form infinity by infinity, because t square by est, if we substitute, we will be getting this form, which is an indeterminate form. So what we do is we apply L'Hospital rule. Now after applying L'Hospital rule as well, we differentiate t square and we differentiate e to the power st, and we still get it to be of the form infinity by infinity, which is again indeterminate form. So we'll again apply L'Hospital rule. So yeah, after applying L'Hospital rule again, we get our function to be 2 by e to the power st into s square, which can be approximated as 0, because if we put infinity here, this term is very large, and hence we can approximate this as 0, and which is a finite quantity. So we did ultimately get what we wanted, which is our function to be equal to 0. So hence we can call this function of exponential order. So yeah, in this question what we understood is how do we make out whether a function is of exponential order or not, and when we get our function to be of any indeterminate form, how do we apply L'Hospital rule and then continue to solve the problem. So now let's solve some Laplace transforms of some standard functions. Over a period of time we kind of memorize the answers to these functions, but for now let's just derive it. So let's say we want to find the Laplace transform of this e to the power minus at. So what is the definition? Based on the definition, if you want to find the Laplace transform of this, this is the Laplace transform of it, e to the power minus st f of t, correct? So now here this is our f of t. So how do we find the Laplace transform? It would just be e to the power minus st e to the power minus at dt. So now we just do normal integration. So yeah, this is the Laplace transform of e to the power minus at. Using the same method, we can prove that Laplace transform of e to the power at is equal to 1 by s minus a. So now let's solve this for this. So again what we do is our Laplace transform form is this f of t dt. Here our f of t is cos at, so use cos at dt over here, and by integration we get this. Substituting the values of infinity and 0, we get this, which is equal to, so yeah, this is the Laplace transform of the function cos of at. So yeah, these are the two formulas that are standard formulas. Using this formula we got the integral for the above formula, and then we just substituted infinity and 0 and we got our Laplace transform. So we can apply the same method and find the Laplace transform of sin at, and the answer will be a by s square by a square.